Hello everyone. So today we are going to be learning something very interesting. We're going to be learning prime numbers. Okay. And when I say prime, I don't mean like prime, like that there was what's it about like something's very important. We say it's prime. Something at its peak is a prime. Or that bottle of whatever it is that can drink was prime. No. Okay, I'm talking about numbers, prime numbers. Now, in the number world, there are only two types of numbers. Actually, there are some numbers that don't fall under either of this category, but never mind. The prime number and composite number. Okay, two types. Now, when I say number, I only mean integers. That means if I have half 0.46.78, these are not part of the numbers. I'm talking about like pure integers. Okay, so just to make it clear, what I'll do is I'll basically just integer over here. So that you know. Because if you're talking about like numbers such as like half, 3/4, they're not gonna fall under either of the category. Okay, this is only purely for integers. Okay, but we don't say prime integers, composite integers. Okay, so don't get me wrong. Alright. So once we've got that settled, let's learn what are prime numbers. Okay. So firstly, we need to learn about something called factors. So what in the world are factors? Now, if I have a number, let's just say n. Okay, mysterious number n. Okay, called n. I don't know why I'm doing this block thing, but okay, let's just do it. Okay. N is something times something. Right? Agree? Now these two somethings are its factor. It's one factor, this is another factor. So what are factors exactly? Now, if I have a number, I'm gonna give you a number. I'm gonna give you the number 24. Now, what are its factors? Now, basically, the definition of a factor is basically if this number is a factor of the other number, that means that other number can divide by this number. Okay, so if I say if A is a factor of B, that means B can divide A perfectly without any remainder. Okay, so just think about it this way. Look, n is a number. It's this times this. Now these two are its factors. Just think about it this way. N is this times this. These two are its factors. Okay? So now that you know exactly what factors, let's try to list down the factors of 24. Pause the video right now, try it out. What are the factors of 24? Okay, so to make it easy for us, what I'm gonna do is I'm just going to show you the what and what give us 24. What times what gives us 24. So 1 times 24 gives us 24. So these two are factors. 2 times 12 gives us 24. These two are also factors. 3 times 8 give us 24. These two are also factors. 4 times 6 give us 24. These two are also factors. Now actually, you could continue on. 6 times 4, 8 times 3, 12 times 2, and 24 times 1. But if you notice, they are literally just a repeat of the previous ones. So there's no need to write it down again. Okay? So now if you look up here again, you can see there are exactly 8 factors. 1, 2, 3, 4, 5, 6, 7, 8. So what I can say is I can say that 24 has exactly 8 factors. Okay? So hopefully you understand what factors mean now. So 24 has 8 factors. So if you look up over here, n equals to this factor times this other factor. That means these two are factors lah. Okay, so factor, I'm gonna write one more time. If A is a factor of B, that means B is the multiple. Okay, this thing will be called multiple. Okay, just for your extra knowledge, this is multiple. So you see over here, multiple, factor, factor, right? Factor, factor. Okay, so this is a factor, this is a factor. You multiply it, you get the multiple, which is in this case n. So if A is a factor of B, that means B can divide A, and you will get a perfect number with no remainders whatsoever. Okay, so now 24 is 8 factors. But let me ask you a question. I want you to pause the video and think about it. Alright, this is my question. What do you think the minimum number of factors a number can have is? Pause the video and think about it. Okay, so you should be done thinking. So what do you think? How many factors do you think at the least any given number could have? Write your answer in the comments below. Right? Think about it. Use your brain a bit. What do you think? Now, if you had said 2, you would be correct. Minimally, a number have 2 factors, and I'll explain why. Now, you know when I expressed the 24 in factors, I wrote it like this, okay, because it's easier for you to visualize. But another reason is this: I want you to realize that when I say factor, I mean this times this, like it's sort of like in this format, right? So, if a number at the least can have 2 factors, what would the 2 factors be? Obviously, it will be in this format, this times this. That means it can only be this times this equals this number. Let's say this is the right P. Okay, P is going to be like the variable for this number. Now, if P only has 2 factors, it means that only this times this can give you P. No other combination can give you P. And it only means that P can only be divided by this number and this number. Nothing else. Agreed? Now, what do you think these 2 numbers are? Okay. It's super easy. It'll be 1 times P. Agreed? Because this is basic knowledge that 1 times P will equals P. So 1 times, now any number can be divided by 1. Okay, any number, any positive number can be divided by 1. Positive integer can be divided by 1. And of course that number can be divided by itself, right? So 1 times P equals P. Now I'm gonna give you another question for you to ponder on. I want you to try, alright? I want you to pause the video for a minute. And I want you to take out a piece of paper and write down as many P's as you can possibly think. And what do I mean by as many P's? As many numbers that you think can only have this format, 1 times P, 1 times itself, to get this number. As many numbers of P. I'm going to give you one example, one single example, alright? For example, the number 3. 3, only 1 times 3. There's nothing else that can give me 3 except 1 times 3. So I want you to come up with as many of these numbers as possible that only can have 2 factors, and of course, if it's 2 factors, it's only 1 times the number itself. Come up with as many of these numbers as possible and pause the video right now. Okay, so how many numbers do you write down on a piece of paper? Okay, now I don't care what numbers you wrote on your piece of paper, but what if I were to tell you right now that the numbers that is all on a piece of paper, they are all prime numbers. So you get what's prime numbers? We don't even need all these anymore. Now I'm going to explain you what's prime numbers. Okay. Prime numbers, simply put, are just numbers. Okay, prime numbers with only 2 factors. 1. Why is it always glitching? 1 and itself. That's the definition of a prime number. So now let's try to come up with as many prime numbers as possible. So let's go through some prime numbers. 2 is a prime number. 3 is a prime number. Is 4 a prime number? No, because 4 can be 1 times 4 and also can be 2 times 2. So you get what I'm trying to say? 5 is a prime number because it's only 1 times 5. 6 isn't because 6 can be 2 times 3. 7 is. 8 isn't. 9 isn't because 9 is 3 times 3. 10 isn't because it's 2 times 5. 11 is. 13 is. 15 isn't. 16 isn't. 17 is. 19 is. 23 is. 24 isn't. 25 isn't. 26 isn't. 27 isn't. 28 isn't. 29 is. So I want you to try to listen down, write the numbers, alright? Okay. So it's actually quite interesting. Okay. So it's very easy to tell whether it's a prime number or not, as long as it's small enough. Basically, if I'm gonna give you a number, alright, and I want you to try to tell me whether it's prime or not. Okay, here's my number. Is this number prime? It's very easy to determine whether the number is prime or not, as long as it's small enough, as I said. You just need to check if this number can be divided by anything other than 1 in itself. So if I can take 43 and I can divide it by 3, that's it. Then I know it's not. But if 43 can only be divided by 43, can only be divided by 1, then I know it's prime. Okay, so that's literally how you know. And 43, yes, it's a prime because they only 1 times 43. Okay, so that's how interesting it is. Okay, just prime numbers. But there's actually a lot more that we need to cover. Okay, now let's move on to composite numbers. Actually, composite numbers are basically numbers that aren't prime. Actually, technically, this definition is wrong. Okay, but I'll explain why later. For now, just remember this. Composite numbers are numbers that aren't prime. Okay. So, take note of that, remember that. If the number is not prime, it's composite. Okay? That means numbers that have more than 2 factors, essentially. Numbers that have more than 2 factors. Okay, now, we are going to try. Okay, now I'm gonna clear up some misconceptions, some misunderstandings in the mathematical world. Okay, now, there are 2 numbers that I would like you to consider and tell me whether they are prime or not. Okay. My first number is this number. This is not 8. This is 0. Is 0 prime or not prime? Is 0 prime or composite? I want you guys to think about it now. Okay, 0 is not prime. Then a lot of you say, so it's composite, eh? No, it's actually also not composite. So this is a number that is not prime, not composite. Which was why just now, remember I said, do you remember just now I said, composite numbers are numbers that are not prime. But I told you that, well, that wasn't true entirely. Now, this is the reason why it wasn't true entirely. I actually couldn't say that composite numbers are all numbers that are prime, right? Because that wouldn't be true. That's why just now I said actually it's not that true. Okay, the reason why I say it's not as true, because there's actually something that is not prime and not composite at the same time, which is actually 0. 0 is not prime, not composite. Why? Because, just think about it. 0 is it's completely different from the rest of the positive integers, right? And 0 can't even divide 1, firstly. It can't even do that. It's a number that's just like a nothing, it's non-existent, okay, but not imaginary lah. I'm trying to say that 0 is like a number that is like has no value, and we can't be talking factors in front of 0 because 0 is a completely different thing. Okay, of course, negative numbers they are not supposed to be taken into consideration. Okay, we are only taking into positive numbers at 0. Okay, this we are only talking about positive integers at 0, and 0 is special case because 0 is neither prime nor composite. Okay, so that's why just now I said composite numbers are numbers that are not prime. Well, actually I couldn't say that, right? That's what I said. So now the new definition sort of is composite numbers have more than 2 factors. That's a real definition. So remember that. Don't remember the numbers that are not prime. That was just so that you can quickly remember first. Now here's another number. There are only 2 numbers. 2 numbers out of the scale from 0 to positive infinity. There are only 2 numbers from this entire scale that is neither prime nor composite. But the funny thing is, you don't even need to look at over here. is all squeezed over here. Firstly, 0. Now, funny thing is, these two numbers are also small. The other number may surprise you. Actually, it won't lah. This is 1. Now think about it. Why is 1 neither prime nor composite? Okay, now, here's the thing. 1, now the definition of prime is only has 2 factors, 1 in itself. But if you think about it, it itself is 1. When I said a prime number has 2 factors, 1 and itself. But in this case, itself is already 1. Which basically means that this part, you can't talk about this part. You can only look at here. And that sort of means that this number only has 1 factor. And like how 0 is, it sort of like defies physics. It defies the reality. 1 factor only, wait, what? That doesn't make any sense, right? So that is why we cannot say that 1 is prime, because it fails the definition of 1 and itself, because itself is not there. And it's also not composite because it doesn't have more than 2 factors, it only has 1, right? So that is sort of like crazy. Okay. So hope you enjoyed all this. And consider liking and subscribing if you did. Thank you very much. And if you have any questions, you can drop them down in the comments below. I will be sure to answer them. Share this with anyone who you think will be interested in it. Thank you very much and goodbye. Peace.